In this video, I'll be going over lesson 12, which is about probability models. Our first question says that a bag contains 13 blue marbles, 9 red, and 10 yellow. What is the probability of randomly drawing a yellow marble? Okay, so for this question, we're going to set it up the same way we've been doing before, like in lesson 11. So we want to have our total number of marbles on the bottom, and then on the top we're looking at the probability, and here it's asking us of the probability of drawing a yellow. So we want the number of yellow marbles to go on top. Okay, so I know that there are 10 yellow marbles, but to figure out the total number of marbles that I have, I need to add all of my colors together, which means I have 13 blue, plus those 9 red, plus those 10 yellow. That is going to give me my total. And to make sure you don't make any mistakes, you can absolutely type this into Desmos. So 13 plus 9 plus 10, which gives us 32. So that means that 10 over 32 is our probability of drawing a yellow marble. You can simplify this, right? I can divide both top and bottom by 2 because they're even. So 10 divided by 2 is going to be 5. Let me delete these to get them out of the way. 32 divided by 2 is going to be 16. So when I simplify it, I get 5 over 16. Our next question wants us to match the event with the match each event with the event that is equally likely. So what we need to do is figure out the probability of all of these and then match them together with the ones that have the same probability. The first one says rolling an odd number on a 6-sided dice. Well, if I think about a dice, I have 6 options. 1, 2, 3, 4, 5, 6, right? Out of those 6 options, 1, 2, 3 of them are odd. So that means this would be 3 over 6. Right, I have 3 numbers I could roll out of those 6 total numbers. The next one over here says flipping a coin and it landing on heads. Well, if I think about a coin, I can only land on heads or tails. So I have 1 out of those 2 options. I have a 50% chance of landing on heads. Now these two actually go together because 3 over 6 can simplify to 1/2, which means that those probabilities are the same. So these two are a matching pair. The next one says drawing a diamond from a standard deck of cards. Well, think about a deck of cards, right? A deck of cards has 4 suits. It has hearts, diamonds, spades, and clubs. So one of those 4 suits is diamonds. Here it says I am pulling a red marble from a bag that contains 1 red and 3 blue. Well, I have 4 total marbles here, right? 1 red plus those 3 gives me 4, and only one of them is red. These two are also a pair, which means that these ones down here are also going to be a pair. When I'm rolling a 2 on a 6-sided dice, there's only 1 2 out of those 6 total options, so 6 numbers that are on a dice. And same thing over here, there's only 1 6 out of those 6 different options that I have when I'm rolling a dice. So make sure that when you are doing this question on your workbook that you're looking, because this is like one of the drop down you have to pick and choose. Make sure that you're looking at the numbers and the words of each of these very carefully, because the course will put in small little words to try and trick you. So make sure you're looking at it, double check it. And our next question says that a bag of marbles contains red, blue, yellow, and green marbles. The probability of pulling a yellow marble is 0.25. Which bag of marbles is a good model for this probability? Select all that apply. Okay, so there are 4 colors in this bag of marbles, and pulling a yellow marble is 0.25. 0.25 is another way of saying 1/4. So with probability, I think it's easier to look at it with fractions just because it makes a little bit more sense, because that's how we write these probabilities, right? The number of outcomes over the total. So if you don't know what 0.25 is as a decimal, if you type it into Desmos and then hit this button over here, it will tell you what that decimal is as a fraction for you. So you always have this option if you are given decimals. All right, with that being said, what we need to do now is go through each of these options and figure out which ones give me the probability of 1/4 for yellow. For A here, I have 3 yellow, and remember that needs to go over the total. So I have 3 plus 3 plus 3 plus 3, which is 12. That simplifies to 1/4. And again, you can always simplify your fractions in Desmos if you would like. Here I have 4 yellow, and I have 1 plus 4 plus 1. Remember, I'm adding these colors here to get my total, which is my denominator, and that is 7. Well, 4 over 7 is not going to simplify to 1/4. For this one here, I have 1 yellow out of 4. That one works. Here I have 4 yellow out of 10, and this simplifies to 2 over 5, which is not 1/4. So again, to get those denominator numbers, I was adding together all of the marbles. So for example, D, I would do 4 plus 1 plus 4 plus 1, and that's how I got this 10 here. All right, next question. Next question says that Joey spins a spinner 60 times and it lands on purple 20 times. Which spinner is the best model for this experiment? Okay, so he spins his spinner 60 total times. So that means 60 is going to go on our bottom, and it landed on purple 20 times. Okay, so if I want to simplify this, if I were to simplify it, I'd get 1/3, which means I am looking for a spinner that has 3 sections, okay, and one of those sections is purple. If I look at this first one, this one can't be true because there's 5, right? There's too many different sections. I'm looking for just 3. This one right here, this is a 50-50, right? It's cut right in half. It's like if you were to take a pizza, cut it right down the middle. Purple is going to be eating half of this pizza, but purple only wants to eat 1/3. This one down here is the one that we want. So orange, green, and purple are all broken into those 3 separate sections, and one of them is purple. Next question says that Frank performed an experiment in which he randomly pulled a marble from a bag, recorded its color, put it back, and then repeated. The following table represents the number of times each color of marble was pulled. Which of the bags of marbles are good models for this experiment? Select 2 that apply. Okay, this one is a little bit trickier in the sense of we just have to be a little bit more careful in the answers that we're choosing here. Okay, so when I am looking at my numbers from the table, I see that purple has the most and blue has the least. Right? And then green, red, and yellow, these are all the same. So when I'm looking at my bags of marbles here, I want to pick a bag where purple has the most and then blue has the smallest amount, or somewhere close to it. Now, if I really look at all of these numbers here, they're all pretty close to each other. Right? It's not like I pulled green once and then I pulled red 30 times. They're all around 8. Yeah, purple and blue are a little bit one more and one less, but they all have around 8, which means that you could also argue that there's the same amount of marbles for each one of these colors in that bag, which is why we're pulling them about the same amount of times. So if I look at my answer choices here, B and D all have the same amount of marbles for each color in the bag, right? B has 3 green, blue, purple, red, yellow, and D has 1 of each of the colors. So because when I look at my table, all of those numbers are about the same, right? They're all around 8. That is how I came to the conclusion of there's probably the same amount of marbles for each of those colors in the bag. Alrighty, next question says that on a spinner, there's a 25% chance of it landing on an orange section. Which of the spinners are a good model for this situation? Okay, so 25% chance, that's the same as 1/4. So if I think about a pizza, right, and I cut it into fourths, 1/4 of the pizza is going to be like this. It's going to be a small quarter like this. So what I'm looking for in these spinners is I'm looking for this colored in section to be orange. If I have an orange, this one down here doesn't even have orange, so don't pick that one. An orange section has to look like this, so it has to kind of have this shape to it. It can't be bigger, it can't be smaller. If I look at this first one over here, this orange section is too big, right? It needs to cut off like right here. That's the orange section I want, which means I don't want any of this. So that one unfortunately cannot be it. However, both of these two over here have the perfect orange section, right? The orange section of these spinners is 25% or 1/4 of that spinner. Our next question says that Jackson performed an experiment in which he randomly pulled a marble from a bag, recorded its color, put it back, and then repeated. He did this 44 times, and 18 of those times he pulled a green marble. Which of these bags of marbles best models this experiment? Okay, so he did it 44 times was his experiment, and 18 of those times he pulled green. So this is the probability of a green marble. Let's simplify this fraction to help us. So I'm going to type it into Desmos to help us simplify it. I'm going to hit this button over here, and it tells me 9/22. So that means that when I am doing these, or when I'm looking through these different answer choices, I want to find one that has a 9/22 chance for pulling a green. So if I look at A, there are 9 green. If I add all the other colors together, so 5 plus 9 plus 4 plus 4 to get the total number of marbles in that bag, I would get 22. So that one, the first one out of the gate, that one works. The reason why B is wrong, and they put this in here to probably confuse you a little bit, is because yes, there are 9 green, and you might be going, oh, the 22, 9/22. Remember, you have to add the total, which means I need to take 22 and add it to 9, and that would actually give me 31. So remember that your denominator here is always when you're adding all of those marbles in this bag together. So the bottom is always going to be your total when we're talking about probability. All right, next questions is that 10 students were chosen at random from a 7th grade class, and 3 of those 10 students named chocolate as their favorite candy. Which surveys shows the results that best modeled this experiment? Okay, so 10 students were chosen. 3 out of those 10 chose chocolate as their favorite. Okay, so I'm looking for a 3 out of 10 or maybe a 6 out of 20, right? Both of these are the same fraction, just written slightly different. So let's look at this first one here. For chocolate, I have 3. And add up the total number of kids. 10 plus 3 plus 3 is 16. So nope, not the same. This one over here, I have 9. 9 plus 6 plus 5, that gives me 20. Close, but nope. This one over here, I have 3 who like chocolate out of 23. Again, adding these together, 10 plus 10 plus 3 gives me that 23. Nope, which means it should be this bottom one down here. Let's double check it. I have 9 out of, if I were to add 9 plus 9 plus 12, I get 30, which simplifies to 3/10. Perfect. So that table works. All right, and that is the last question for lesson 12. If you have any questions, please let me know. Other than that, have a great day.